All right, you guys, we're gonna continue here. I might zoom in just a little bit, start over here, and actually let me readjust. All right. We're going to, I'm gonna highlight what we're doing. We're gonna graph linear functions with a restricted domain. Okay. So we're gonna do what we did, but you know, you can't always, and here's our learning target. I can make a graph of a linear function on a restricted domain. That means we're gonna have to say we can't put everything in. All right, so if we read this, it says, unless otherwise stated, a function is assumed to have a domain consisting of all real numbers, for which the function is defined. Many functions, we've done linear, we did that in Algebra 1, quadratic, exponential, all Algebra 1 skills are defined for all real numbers. So their domain is all real numbers. So if I was going to write all real numbers, there's a few ways to write it. I'm not really great at this script lettering, but I'll give it a shot. All right, we can. There's a way to write script, and that's terrible. It's supposed to be a script R. Set numbers as an inequality, right? So it would be from negative infinity up to positive infinity. All right, and set notation, we'd say the same thing, but we'd use that brace and X bar, right? Negative infinity up to positive infinity with our brace at the end there, so you can see it. And for interval notation, we cannot touch infinity, so we will do this. All right. So here we go. And we'll show you how to do this. Some real-world situations can be modeled by math functions, but the set of real numbers would not make sense of the situation. In these cases, we need to restrict the domain. Okay. If the rule of a function and its restricted domain are given, you can draw a graph of the function and identify the range. So that's what we're going to do. We're going to graph this function with our restricted domain, and then we're going to say what the domain is. So here we go, we got this equation. We have a restricted domain. So we really only need 2 points, all right, to make a line. So we're gonna take these x values, these are the list of my x values, and plug them into this equation. Let's start with -4. So I'd say, hey, you know what? A function of -4 is equal to 3/4 times -4 plus 2. Which equals, this comes out to -3 plus 2. So I say when I plug in -4, which is all I did, I took this x value over here, part of my domain, and when I plug in -4, I can answer -1. So I know one point is -4, -1, my x and my y value. This gives me another x value, right? This guy over here says, hey, you know what? What if we go from -4 all the way up to another positive 4x value? So let's do that. Let's say, what if I plug in 4 into this equation? 3/4 times 4 plus 2. So a function of 4 is equal to 3 plus 2. A function of 4 is equal to 5. So when I plug in -4, I get -1. When I plug in positive 4, I get 5. So we can graph that pretty easily over here. Let's do it. Let's graph -4, -1. So -4, -1 gives me a point right there. It's I filled that in solid. Let's make sure that's a well, yeah, that's a hard stop. It's a bracket instead of parentheses, so that's a solid. Means I touch it, right? I also touch 4, which has an output of 5. So with an x value of 4, I have a y value of 5. And I touch that as well, and there's my graph. All right. That just means I restricted my domain. I don't keep going to the left. I don't keep going to the right. And I have a range. That's how far up and down. I'll start with my lowest point. I touch -1 and go up to my highest point. It looks like I touch 5, right? And there is my range for that domain. So I'm going to do a couple more of these with you. And then we'll pause, and we got another piece of paper that we'll do on the next graph right there. Let's come down and do this guy. So, wow, this one says, hey, you know what? I go down to -3, okay, but I'm bigger than negative 3. So I really only have 1 point to go on. So let's get our starting point. Let's say, hey, my domain is restricted numbers bigger than negative 3. So let's find out where that negative 3 is. I actually already have 2 points. You notice over here my slope is negative 1 over 1. And my y-intercept is negative 2. I have a point right here at negative 2 already. Let's get that other point. Let's get this negative 3. If I plug in negative 3, I've got an output of negative 3 minus 2. So all I did is I plugged in my negative 3 there and there, which gives me 3 minus 2. Well, when I plug in negative 3, I get 1. So when I plug in negative 3 right here, I get an answer of 1. And I've already got 2 points, right? So all I have to do is and we'll figure out a little bit here. I've drawn this without actually figuring out whether that's an open circle, meaning that I include that or don't. And if I come over here, there is no equal sign. So x is never actually equal to negative 3. It's just greater than. So it goes all the way up to negative 3. I'm going to put an open circle there. I know it looks filled in, but it is not. It's an open circle. All right, so there's that graph. We're left to find the range. Well, it looks like my range goes down forever, and we always start at the smallest point, so it goes down to negative infinity, and it only goes up to 1. And it looks like it doesn't quite touch 1, so we're going to use soft endings. We're going to use these parentheses instead of brackets. All right. Now, there are 2 reflections. I'm going to highlight them. I want you to talk. This is going to be a discussion point for you and your group the very next day. All right, so we've got these 2 highlighted. It's not something we're going to do together right now. And then I'm going to come and do one more of these and pause. I'll let you finish the last one. All right, so here we go. Looks like my graph could use a little work. I don't know if it's a little better on yours, but we'll see if we need it. So this gives me my domain. So my domain goes from negative 6, it goes from this x value with some y value we don't know, all the way up to positive 2, again with some y value we don't know, but we have an equation. Your function is defined like this. So we're going to go ahead and plug in those 2 points. Will give us 2 points, and that's all we need to draw a graph of a line. So we'll plug in the domain of 6, the x value of 6, negative 1 times, I guess that's a negative 6 plus 2, which function of negative 6 equals, well, we got negative 1 half, and negative 6, which is 3 plus 2. So I get negative 6, 5. I'll go ahead and make that happen over here. I'm going to come over here, we'll find negative 6 and go up to what I perceive to be 5 and put a little dot there. We can figure out these way to situate myself a little bit better. Kind of wrapped around the camera right here. And then I've got a function of, let's find this other one, a function of 2 equals negative 1 half times 2 plus 2. And let's just go ahead and do this in our head real quick. Negative 1 half times 2 is negative 1, plus 2 is 1. So when I plug in 2, I get an output of 1. So when I plug in 2, I get an output of 1. That's right there. All right, I'm going to look over here, and it looks like I touch negative 6. So I'm going to make sure that's a hard stop right there. And I don't touch negative 2, so I'm going to do or positive 2. I'm going to do an open circle here. And then I'm going to connect those with a straight line like this. And there's my graph. And I should be able to figure out the range. And we're going to do this using the same format, inequality, right? So we got a y. Looks like the lowest y is 1, and we don't touch 1, right? At least put kind of a colon there. Looks like my highest y goes up to 5, and I do in fact touch 5. All right, so those are examples. I'm going to come over here, and I'm going to highlight D. It means I would like you to try D on your own. And this is what we're going to share with our group when we get back. So all the highlighted portions is what you share with your group. We got one more little section after this. I'm going to pause and post.